Everybody, homework help video here for the Pythagorean Theorem worksheet. And for this one, I only assigned evens. So I'm going to go through a few of the evens, not all of them, but a few of them. So evens, remember evens are 2, 4, 6, 8, etc. Now this is all about the Pythagorean Theorem. And just a reminder, the Pythagorean Theorem is a squared plus b squared equals c squared. And that's where the a and the b are always the legs. Those are the smaller sides of the triangle. So for instance, if I looked at number 1, the 6 and the 8 would be the legs. And really they can be switched around, but as a rule of thumb, just go smallest to largest, so A and B. And then the largest side is always the C, and that's the hypotenuse. Hypotenuse. And I wrote it here, I want to write it here as well. Okay, so that's our C. And one way you can tell what the hypotenuse is, if you're not sure, if they kind of look like they're the same or if they're not labeled, like for instance in, I don't know, number 9, if you're not sure if which side is the longest side, you can always find that right angle and go across from it. And whatever is across from it would be the hypotenuse, because that is always the longest side. All right, so let's go through one from this first part. It says, do the following lengths form a right triangle? Well, how do we know? The way we can tell is if a squared plus b squared equals c squared, because a squared plus b squared equals c squared is the Pythagorean theorem. So if it's true, then it's a right triangle. So let's take a look. Since I said evens for this one, let's just do number 4. If we go smallest to largest, this would have to be a, this would have to be b, and this would have to be c. So I would say 3 squared plus 4 squared equals 5 squared. And now a lot of people might make the mistake of just doing 3 plus 4 equals 5, and 3 plus 4 doesn't equal 5. That is not the same as 3 squared plus 4 squared equals 5 squared. The Pythagorean theorem, as we proved it in last lesson, clearly is a squared plus b squared equals c squared. So a squared, if I actually simplify this and see if they're equal, we want to know if they're equal. 3 squared is 9, 4 squared is 16. So if I add those two together, you get, what do you get there? You get 25. And is that equal to 5 squared? Why, yes, it is. 5 squared is 25. So if they are equal, that means that a squared plus b squared equaled c squared, and it is a right triangle. All right. And we answered the question. It is a right triangle. Now let's try it for a different one. Let's go to like number 6. Actually, I'm going to do number 5 because I want you to be able to do number 6. We're going to do the same idea. It tells you what A, B, and C are. Just plug them in. There's not a triangle given. It's just saying 6.4 squared plus 12 squared. We want to know if that equals, question mark, 12.2 squared. So I know 12 squared is 144. That's the only one that I know by heart. So you're going to want to use a calculator for some of these. So have a calculator handy. 6.4 squared would be the same as 6.4 times 6.4. I get 40.96. And when you add those two together, plus 144, I get 184.96. Now, if 12.2 squared equals that, then it's a right triangle. So 12.2 squared is 144 or 148.84. They're not equal, which means this is not a right triangle. All right, so that's how you can use the Pythagorean theorem to check if you have a right triangle. And again, you'll be doing that for number 8. Now, since we have, let's see, I said to do evens. The rest of them are just taking a specific 2 sides and trying to find the third side. So I'm going to do maybe 3 of these. So let's start with the first one, number 8. I want to find the third side. And I can tell from that it's either B or C, that third side. And since it's across from the right angle, that's our C. So we're trying to find C. And then this would be A and this would be B, going smallest to largest. So if I use the Pythagorean theorem, I would plug in 3 for A. So 3 squared, that's squared, plus 6 squared equals C squared. And now my job is to solve for C. So 3 squared I know is 9. 3 times 3 is 9. 6 squared I know is 36. So 36 plus 9, you can check that, is 45 equals C squared. Okay, now that gives us C squared, but how do we find C? Calculator. On your calculator, to get C by itself, that's where we do the opposite of squaring something, and that would be square rooting it. That would give us C by itself, and I just have to take the square root of 45. So find the square root button, 45, close the parentheses, enter, and I get 6 point, it says round to the nearest tenth, so we're going to do 6.7. My answer for C is 6.7. And if you look at the triangle, it looks like it should be a little bit bigger than the other, the B. So that is a little bit bigger. That's perfect. Let's jump to the second page. I'd like to go to number 16. Okay, number 16, we have 3 sides again, and we're trying to find one of the missing sides. And in this case, if I look at the right angle, across from that is 11, so that is the C. So we're not finding C this time. 3.9 is the smallest, so that's right. And we're trying to find B. So if I plug them in for the Pythagorean theorem again, here's where it's a little bit different than the last one. A squared would be 3.9 squared plus B squared. We don't know the B. And the C squared is 11 squared. So let's simplify some things here. 3.9 squared, I don't know what that is, so I'm going to have to multiply 3.9 by 3.9 on my calculator, and I got 15.21. Plus B squared equals, I know 11 squared is 121. You could check that on a calculator as well. Now here's where it's different. In the last one, if you look back, we actually added the two together because they were on the same side. But the two values that we have are on different sides of the equal sign. So so this is where we think back to how we solve equations in general. And subtracting 15.21 to get rid of that and get the B squared all alone, I have to do that to the other side as well. 15.21. Now you can write that out or you can check it on your calculator. For the sake of time, I'm going to do 121 minus 15.21. I got 105.79. All right. So B squared is left on the left side, and that's equal to 105.79. So we just have the last step, and that would be to do the square root. So if I take the square root of 105.79, I get 10 point, if I round it to the nearest tenth, it's 10.3. There you go. So it's not the smallest, but it's not the biggest. We're going to do one more. I'd like to go to, let's just do number 18 right away. Okay. That'll give you a handful of them, and you can follow the same rule and check the other ones the same way. So using Pythagorean theorem to find a missing side, because again, these are right triangles, and the Pythagorean theorem only works for right triangles. And since we see that right angle, we know it's a right triangle, and we can also tell what the hypotenuse is right away. So that's C. Now it looks like this is smallest, so we're going to say that's A and this is B. So we're going to go with that. It's okay if A and B are switched around. It won't change anything. So A squared plus 9.7 squared equals 13.3 squared. All right, let's do some math. 9.7 squared on my calculator, because I don't know that by heart. So that's one thing I can simplify. So A squared plus 94.09 I got. And then 13.3 squared, I got 176.89. All right, now if I want to solve for A, I'm going to first have to get rid of this 94.09 that's next to it, that's added to it, cancel it out, subtract 94.09 here. So 176.89 minus 94.09 gets me 82.8. And finally, to get the A, because we don't really care what A squared is, we care more what A is, we have to do the square root. And that'll get us A by itself. Square root of 82.8. And I get, rounded is 9.1. And there's my A. So it was slightly smaller than the other leg. So that's how you can use the Pythagorean theorem at its most basic form for finding missing side lengths. Again, what we're going to do more in this lesson this week is work more using that and also using it to apply it to different situations. So if you have further questions, make sure you ask. But there's a little overview of the Pythagorean theorem worksheet here to start lesson 24.